Recording in progress. Hi students. In this lecture, I am going to discuss problems based on total internal reflection from previous year's IIT. Let us see first one. Let's see the question. A glass prism of refractive index 1.5 is immersed in water and its refractive index is 4 by 3. A light beam incident normally on the face AB is totally reflected to reach the face BC if. So asked for 3 marks in 1981. So falling on AB normally, now it has to reach the face BC after total internal reflection. So for this, we have to focus what is the condition. Okay. Let us see how to solve it. So first make the diagram given. So it is now given a right angle triangle. So which is immersed in water. So this is A, this is A, this is B, and this is. Now light ray incident normally on AB. Okay. So you can take this is B. So falling on AB normally, it has to reach BC after total internal reflection. Okay. Then see what we can say here. This angle is now theta. So reflecting completely. Now focus here. This is 90. This is a theta. This will be 90 minus theta. Then angle of incidence will be theta. Cross check once. This is theta. This is now 90. Then this angle is 90 minus theta. Then this will be theta. So angle of incidence is theta. If theta is greater than critical angle, then light undergoes total internal reflection. Let us take now sine on both sides. Sine theta greater than sine C. Okay. And we are knowing that sine C equal to mu rarer by mu denser. Okay. It is now traveling from glass to water, right? Glass is now denser medium, water is now rarer medium. So this is now sine theta greater than mu rarer means this is water, which is a 4 by 3. 4 by 3. Mu density is now glass, that is 3 by 2. Because you can see 3 by 2 is greater than 4 by 3. So light ray traveling from denser medium to rarer medium, right? So glass to water, okay? So it should be greater than 4 to 8 by 9. That means if sine theta is greater than 8 by 9, then light ray undergoes total internal reflection. Okay. So you can see it is option A, right? It is option A. See next one. A beam of light consisting of red, green, and blue colors is incident on a right angled prism. The refractive indices of the material of the prism for the above red, green and blue wavelengths are 1.39, 1.44 and 1.47. Okay. So these are the refractive indices. Now see what we have to calculate. The prism will, diagram is given here. The prism will separate the red color from the green and blue colors. Separate blue color from red and green. Okay, let us see first of all how to decide these options. Right. First of all, make the diagram given. It is a right angle triangle. Right angle triangle. This angle is given 45. So here light rays are falling normally on this face. So normally means here there is no deviation, right? It is simply going like this. Now take normal at the surface. So 45, this is 90, this is a 45, right? This is a 45. Now this also 45. This is now angle of incidence. So for all colors, angle of incidence is the same. If angle of incidence greater than critical angle, then light undergoes total internal reflection. Okay, let us take now sine on both sides. Sine I, here I means 45. Sine I greater than sine C. Sine C means it is 1 by mu, right? So what we are focusing is here, if angle of incidence greater than critical angle, then those colors will undergo total internal reflection. So taking sine 45 greater than sine C. Sine C means 1 by mu. This is 1 by root 2, right? So that implies 1 by root 2 is greater than 1 by mu. So from this we can say mu should be greater than root 2 to have total internal reflection. Now see values given. It is given red, green and blue corresponding wavelengths, for corresponding colors, refractive indices 1.39, 1.44, 1.47. And we got condition here. If mu value greater than root 2, those colors will undergo TIR, total internal reflection. Root 2 means 1.414, right? 1.414. You can see here green 1.44, blue 1.47. For these two, mu value greater than 1.414. That means these two undergo total internal reflection. That means they will come like this. And red is now undergoing refraction. Okay. That means we can say that separate the red color from green and blue because these two having only reflection. So correct option is it is A. Okay. See next problem. A right prism is to be made by selecting a proper material and the angles A and B. Condition is given B less than or equal to A. Okay. As shown in figure, it is desired that a ray of light incident normally on the face AB emerges parallel to the incident direction after two internal reflections. We can see diagram here. Condition is incident normally to the face AB. Okay. Now, condition is after two reflections, it is again parallel to the instant one. Now see options. What should be the minimum refractive index for this to be possible? And next, n equal to 5 by 3, where n is refractive index. Is it possible to achieve this with angle B is equal to 30? So asked for 7 marks in 1987. Let us see first of all, what should be the minimum refractive index for this to be possible? Okay, right. Let us make a diagram, the given diagram. Given right angled triangle. Wait, it is given right angle, right? So it is now given AB. This is AB. Given right angle. Now light ray instant normally on AB. This is C. Instant normally on AB. After two reflections. After two reflections, it is again parallel to the instant ray. So this is the condition given. Okay. Now see what we can do. This is instant ray and this is reflected ray. Right. Let us take here normal at the point of instance and here also condition given that B less than or equal to A. Okay. Let us take this is now angle of instance that is I1. Right. Angle of instance I1. Right. Then see what we can say. This is I1. Remaining is now 90 minus I1. This is 90. Okay. Now we can say this is 90 plus this angle is given as A. That is A. This is 90 minus I1 plus 90 minus I1 is equal to 180. So sum of the angles in a triangle equal to 180. So 90, 90, this is 180. From this we can say I1 equal to A. Okay. Now coming to here, let us take this angle of instance is I2. Okay. Now again see carefully. This is 90. This is B. This is I2 means angle of reflection also I2. This is I2 means remaining is now 90 minus I2. Right? So 90 plus B, 90 minus I2 equal to 180. That implies I2 is equal to B. Okay. Next. See here the basic condition is light undergoes total internal reflection. And again here also same thing. And this happens if A is greater than C, B greater than C. Then only light undergoes total internal reflection, right? That means now what we can say from diagram A plus B, this is 90. So sum of these two angles must be equal to 90. So condition 1, A plus B, that is 90. because sum of the angles in a triangle equal to 180. This is 90. But we know that A greater than C, B greater than C. That means we know that A plus B is greater than 2C. But what is the value of A plus B? That is 90. 90 is greater than 2C. 2 here 45 times. That means 45 is greater than C. Okay. So now I am taking a sign on both sides. Then it is sine 45 greater than sine C. Sine C means it is 1 by mu, right? So sine 45 means 1 by root. 1 by root 2 greater than 1 by mu. So this implies mu greater than root 2. That means it's asking now minimum refractive index. Okay. That means minimum value how much? It is root 2. Right? That means if it is slightly greater than C, if A value slightly greater than C, B also slightly greater than C, then sum will be equal to 2C. Okay. Then mu value slightly greater than root 2. Okay. Now see in that second part. So in that second part, given refractive index 5 by 3. So they have taken notation N for refractive index 5 by 3. From this we can say critical angle equal to 37 because sin C equal to 1 by mu means 3 by 5, right? 37. Next, is it possible to achieve this with the angle B is equal to 30 degree? Okay. Question is it possible to achieve this with the angle B equal to 30? If B value 30, now see carefully what happens. A value 60, right? A 60 means here angle of instance equal to 60 because I1 equal to A. Okay. So angle of instance 60. C value 37. So 60 greater than 37. So light undergoes total internal reflection here. Coming to here at this point, I2. I2 equal to B. But B value how much? 30. But what about C? It is 37. That means I2 is less than C. So here reflection is not possible. Means reflection completely not possible. That means this is not possible. Okay. When theta equal to, sorry, when B equal to 30, this condition is not possible. Okay. Right. Let us see next problem. Light ray is incident on the planar end of a transparent cylindrical rod at an angle alpha with the north. Find the minimum value of refractive index of the rod so that light does not emerge light does not emerge through the curved surface of the rod irrespective of the value of alpha. Okay. So asked for 8 marks in 1992. So condition is given cylindrical rod on plane end. Light is incident. Angle is alpha with north. So irrespective of the value of alpha, light does not emerge through the curved path. Okay. Let us see how we start this one. First make a diagram for this one. It is cylindrical. This is now plane part and this is now curved part. So light is incident at an angle alpha with the normal to the plane part, that is alpha. After refraction, it instants now on the curved part. Take normal. This is angle of refraction. Now this becomes angle of incidence, and we can say that that value will be 90 minus r, right? Okay. Now focus here. How to solve this one? First of all, write condition for this boundary. Snell's law. It is mu1, that is 1, sine alpha, that is equal to mu2, that is mu, which we have to calculate, sine r. Okay, this is equation 1. Now condition is, so here angle of incidence is 90 minus r. Okay, 90 minus r, that is angle of incidence. Now this must be greater than or equal to c. Equal to in the sense slightly. Okay, means if this angle is slightly greater than c, it will undergo total internal reflection. Okay. Now see what we can do here. So first of all, I am taking here both sides as sine. So from this I can say sine of 90 minus r is greater than or equal to c. So it is sine side sine c. If I am taking limiting case, 90 minus r is greater than, sorry, it is equal to c. Take limiting case. Then cos r equal to sine c. Sine c means 1 by mu. Okay. Now focus carefully. He is saying that irrespective of the value of alpha. Okay. Then the meaning of that. When alpha is increased, r also increases. Okay. Now what can be the maximum value of alpha? It is maximum value of alpha. That is 90. Means if I'm taking angle alpha slightly less than 90, it is slightly less than 90. So in that case, R value will be maximum. When R is maximum, 90 minus R is minimum. If minimum value, I can say here, if minimum value is greater than C, then any value will be greater than C. So focus this sentence carefully. If minimum value of this is greater than C, then any value will be greater than C. Okay, right. That means now taking alpha value 90. When alpha is 90, sin R is equal to 1 by mu. See carefully. I am taking alpha 90. Sin 90 is 1. So sin R equal to 1 by mu. Here we got cos R equal to 1 by mu. So sin r equal to 1 by mu. This is a cos r equal to 1 by mu. That implies from this to what we can say. From those two we can say r must be equal to 45. Okay. So r value 45 means cos 45 1 by root 2. That means mu value is root 2. This is minimum value. If mu value is root 2 means minimum root 2. That means what we can say here, mu value should be greater than or equal to root. Then irrespective of the angle of alpha, this will always reflect like this. That means light does not emerge from the curved part. Okay. So I hope you got a clarity. Let us see now same question asked in 1979. Question same, only changes. It is just slightly modifying the shape of the object. It is now cubical transparent glass block is placed on a printed page lying on a horizontal surface. Find the minimum value of refractive index of the block so that printed page is not visible through the vertical faces. Students, the previous question and this question both are same. The only change is it was cylindrical shape. This is now cubical shape, except that remaining as it is. See once here, shape is now cubical. Placing on a printed page. So light rays. This is alpha. Then they will fall on the vertical face. They should undergo TIR. Okay. Again, this is alpha. Sorry, this is R. This is 90. This is now 90 minus R. If 90 minus R greater than or equal to C, this undergoes total internal reflection, right? Again, same equation 1 into sine alpha is equal to mu into sine R. When alpha is 90, means when alpha maximum, R is maximum. Maximum value of alpha is 90. When this is 90, sine R equal to 1 by mu. Same as the previous problem. Taking sine on both sides, this becomes cos R. Cos R. If you take limiting case equal to sine C 1 by mu. Sine R 1 by mu, cos R 1 by mu. That implies R value 45. That means again mu value, minimum value must be, it is root. So greater than or equal to root 2. So both questions are same, just slightly modified. So one is asked in 1979 and the previous one 1992. Questions are same. So I hope you got the clarity.